Assalamualaikum and good day to all panels, Dr. Fauzi and Prof. Zulkifli. My name is Mohamad Fitri bin Mohamad Azli. I am final year student of Faculty of Mechanical and Manufacturing Engineering Technology, University Technical Malaysia Malacca. I will present my title project, The Simulation of Polymer Composite Reinforced with Waste Aluminium Alloy in Plastic Process. My supervisor is Encik Mohamad Khalid bin Wahid. Basically, this is my presentation outline. There are 8 number of contents. I will present the introduction, problem statement, objectives, scope of study, literature review, methodology, result and discussion, and lastly, conclusion. For introduction, firstly, I will introduce about the composite. The term of composite is very familiar in manufacturing students. Composite is made by combining a minimum of 2 or more materials. The aim of the composite is to focus on improving the properties of the materials, enhance the performance levels, and allow new innovations to develop. The composites are also widely used in the wide range of industries, including construction, automobile, transportation, architecture, military, and sports. Secondly, polymer composite. Polymer composite formed by combining different material phases, at least one of which is usually a polymer in the matrix. There are two main stages in the manufacturing of matrix and reinforced polymer composites. Usually, the fiber is as a reinforcement. High-performance composite is mostly suitable in applications for polymer composites. Reinforcement properties are completely different or stronger than matrix properties. Thirdly, I will introduce about the aluminium alloy. Aluminium alloys are alloys in which aluminium is the predominant metal. Aluminium alloys have high specific strength, high processability, predominantly anti-erosion, increased conductivity, eco-friendly nature, and recoverability. Aluminium alloys are widely used in the fields of electric modules packaging, electronic technology, automotive polystructure, wind, and solar energy management. Lastly, I will introduce about the injection molding. The injection molding is a manufacturing process for producing parts by injection molten material into a mold. Injection molding can be performed with a host of materials, mainly including elastomers, confections, and most commonly thermoplastic and thermosetting polymers. The key points in the design of parts for injection molding are described and being setting up a simulation with SolidWorks simulation plastic. Next, I will show the problem statement. As we can see in the figure, there are a lot of small metal chips produced after machining. For manufacturing students, the milling machine usually used for their lab session and project. We can identify small metal chips waste from aluminum alloy produced with high quantity in milling machine process. High costs are used to recycle the small metal chips to be raw material. So, the waste can be reused to be combined and produce new products. For my project, there are 3 objectives that must be achieved. Firstly, to design a new casing phone using polymer composite reinforced with waste aluminium alloy by plastic injection molding. Secondly, to perform the simulation work in plastic injection molding using SolidWorks simulation plastic. Thirdly, to determine the optimum parameter of simulation result. Additionally, the smartphone casing had been chosen for the product because it is simple product that commonly used to all people smartphone protection. There are 3 scopes of work in my project. Number 1, Use the polymer composite reinforced with aluminum alloy for the material of a new casing phone. Number 2. Design the new casing phone in SolidWorks plastic. Number 3. The simulation of plastic injection molding process is performed in SolidWorks plastic simulation software. The SolidWorks practice in the class give me some advantage to do my project. For literature review, I will highlight the journal paper that I have used. For polymer composite, the polymer composite were always a mixture of different phases of material, which are at least one of which is typically polymer, published by Rosyanti Rahman et al. 2019. For polypropylene, polypropylene has outstanding chemical tolerance and can be manufactured by several techniques of convention, including such injection molding process and extrusion, published by Hisham A. Madah 2016. For alumina trihydroxide, alumina trihydroxide is a type of flame retardant that has been widely utilized both as a flame retardant as well as smoke suppressor despite its low toxicity, cost advantage as well as its simultaneous operation, published by Kumaga et al. 2001. Lastly, for alumina trihydroxide filled propylene, varying concentrations of ATH are typically applied to PP in order to enhance the flame retardant, published by Rahman Shah et al. 2013. Then, I will explain the methodology of my project. The figure shows the flowchart of the experiment. The flowchart uses spatial shapes to present different types of action or steps to perform my project process. For the design of product method, the design of product is designed in SolidWorks 2017 software. Then, use the actual dimension of iPhone 8 Plus smartphone. After that, sketch the design with accurate dimension. Lastly, make the sketch to SolidWorks 3D drawing. In the simulation plastic of product, the figure shows the step of the flow simulation plastic. The first step is insert the injection location. The injection location is where the cavity is filled from the runner system in plastic injection molding. For simulation plastic, the injection location had used 1 point injection location. The size of point injection location was 2 mm. Second step is insert mesh process. The face of casing phone part must be selected to be mesh process. The type of mesh used was solid mesh, tetrahedral hybrid. After the face of part had selected, the mesh can be created. The size had been set for 2 mm with uniform size. The third step is insert polymer material. In SolidWorks plastic, the materials provided with various types of polymer material. For polypropylene aluminium trihydrate composite, the material needed to be custom with its properties. After the material had been custom, the material can be applied to the casing phone part. The fourth step is field setting setup. The field settings define the injection molding process parameters such as filling time, melt temperature, mold temperature, and injection pressure limit. The fifth step is run the simulation. After completing the input data for mesh, material, process, parameters, and boundary conditions, the plastic simulation has been run. The sixth step is result simulation. There were many results can be viewed after the interest both during and at the end of the filling phase after a successful run of the fault analysis module. The seventh step is summary model and flow. The figure shows all the summary model and flow after successful run of a flow analysis module. The next step is general report. The report describes the full information and results from the simulation plastic, and the generic report showed the material properties analysis, full setting analysis, flow summary analysis, and important the flow simulation result analysis. Then I will explain the result and discussion. For model information, as we can see in the table, I will highlight the volume. The propylene aluminum trihydrate gasiform was 10 cm3, which lower than the volume of the propylene gasiform was 10.05 cm3. Furthermore, the mass of propylene aluminum trihydrate gasiform that was 9.16 gram, which is also lighter than the mass of the propylene gasiform was 9.20 gram. For the material properties, the Young modulus for the propylene aluminum trihydrate is 1379 megapascal, that higher than the Young modulus for polypropylene is 1350 megapascal. For the field settings, we can see in the table, the field setting was the process parameter that controls the injected material into the cavity by specifying filling time, injection flow rate, mode temperature, and injection pressure limit. Both simulations use same field setting. For the fill time result, the fill time is the time taken to fill up the part inside the cavity. It is also to show how the plastic material flows to fill the mold. The maximum fill time for the simulation plastic for the gasiform polypropylene aluminum trihydrate was 0.253 seconds, that more faster compared to the maximum fill time for the simulation plastic for the gasiform polypropylene was 0.289 seconds. Then for the pressure at end of the result, the pressure at the end of the field result produced by the field analysis demonstrates the pressure distribution in the cavity as soon as the cavity is fully filled with the polymer. The maximum pressure at the end of field for the simulation plastic of the gasiform polypropylene aluminum trihydrate was 87.578 megapascal, that lower compared to the maximum pressure at end of field the simulation plastic of the gasiform polypropylene was 88.907 megapascal. After that, the sigma result. The sigmas are depression on the surface of the plastic component that is injection molded. The main problem of sigmas is that a component has not been filled with enough polymer molecules to compensate for the shrinkage that happens. The simulation result presented that simulation plastic of the gasiform polypropylene aluminum trihydrate produces higher maximum volume sigma that was 0.098 mm compared to the simulation plastic of the gasiform polypropylene was 0.094 mm. For the weight line result, when two or more plastic mat flow front come together, the weight lines are formed and can be activated by mold shut-off surface. Mold co-features multiple injection position or variation in the wall thickness that cause flow front promotion or hesitation. The simulation result presented the simulation plastic of the gasiform polypropylene aluminum trihydrate produced lower maximum volume weight line that was 146.620 degree compared to the simulation plastic of the gasiform polypropylene was 148.570 degree. Lastly, for the air traps result, at the filling stage, if the air in the mold cavity cannot be vented into the atmosphere, the trapped air can be prevent the plastic content from filling the volume where the air trap is located. The air trap result revealed the simulation plastic of the gasiform polypropylene aluminum trihydrate produced lower the maximum value air traps, that was 0.253 seconds compared to the simulation plastic of the gasiform polypropylene was 0.289 seconds. Lastly, I will explain the conclusion and recommendation. For the conclusion, as a conclusion, the simulation plastic is very important to deliver easy to use for the flow simulation plastic of casing foam, polypropylene, aluminum 300 and polypropylene material. Moreover, simulation plastic can help to recognize manufacturing defects early in the design process, such as component warpage, sink and flow marks, and air traps. In almost every industry, plastic is one of the most widely used materials. Therefore, the objective of the project has been achieved. For the recommendation, the first recommendation is focus about the design of the plastic part. The thick walls can lead to long cycle time and poor mechanical properties. The thinner walls are the easier in the injection molding process. The second recommendation is about material of the plastic part. Always choose the material for a component cavity and mold bodies for use. Last but not least, the recommendation for good quality plastic product in the simulation plastic is suitable for process parameter. That's all for my presentation. Thank you.